A report on the topic is offered for your attention. The use of GIS in renewable energy specialist learning. The global trend of recent decades in the gradual replacement of traditional energy sources with renewable ones for improving the environment, climate change prevention, and others. Aiming technologies that help increase the efficiency of renewable energy resource, RIR, are Geographic Information System GIS. Modern GIS offers a lot of functionality for the entire decision cycle. In particular, for solar generation, GIS can be used for solving difficulties of remote monitoring of sites allocated for solar power plants and assessment of their suitability. Effective management of information on the operation of stations, production and distribution of electricity in real time. Planning and management of energy production resources. With the development of GIS, scientists and energy professionals are finding new and new applications in the field of renewable energy resources. At the same time, it is important to pay attention to the need for high-quality training of highly qualified specialists in the field of RAR in order for GIS to become a truly effective management tool in their professional activities. According to the results of research in the world, in most student training programs in the field of renewable energy resource is insufficient attention paid to the study of GIS, in particular open source software. The educational and professional training program for students measuring in one-for-one electricity, electrical engineering, and electromechanics is focused on training primarily competitive professionals who have developed professional competition in the field of RR, capable of designing, creating, and operating power plants using renewable energy sources. Currently in Ukraine, such specialists are trained in 18 higher education institutions. You can see in figure. Stanytsina National University, named after Yuri Kovach. Kherson National Technical University, National Technical University of Ukraine, Kyiv Polytechnic Institute, named after Igor Sikorsky. National Aerospace University, Zhukovsky Kharkiv Aviation Institute, Kharkiv National University named after Beketov, National Technical University Dnieper Polytechnic, National University Odessa Polytechnic, and in Ivano-Frankivsk National Technical University of Oil and Gas. Education takes place according to the educational programs of the first bachelor's, second master's, and third educational scientific levels of higher education. One of the areas of the potential application of knowledge of future specialists in the fields of renewable energy resources is social and environmental, which should address issues related to the efficient use of natural resources, environmental protection, the openness of government, land management, and more. Most of them are based on the development, implementation, and use of geographic information system and technologies. The functionality of GIS as follows. First, data entry by importing from existing digital datasets or by digitizing sources. Data conversation, converting data from one format to another. Transforming map projection, changing coordination system, storing, manipulating, and managing data in internal and external databases. Map metric operation, geodetic data processing operation, overlay operation, cartographic algebra operation. Special analysis, a group of functions that provides analysis of the location, relationships, or other spatial relationships of objects, including analysis of visibility and invisibility zones, approximately the analysis, network analysis, creation and processing of digital terrain models, analysis of object within buffer zones. Spatial modeling, geomodeling, operations similar to those used in mathematical cartographic modeling and cartographic research methods, visualization of input, derivative or final data, output of data, graphic, tabular, and textual documentation, including its reproduction, documentation, and generation of reports. Maintenance of decision-making process. According to the authors, the need to study GIS by future specialists in the field of renewable energy resource is justified, at least, but professional conditionality and orientation, social significance, and professional demand you can see in figure. The purpose of the discipline is to acquaint future engineers with the theoretical, methodological, and technological basis of the creation and operation of geographic information systems, mastering the general principles of work, and gaining practical skills in using GIS to solve applied problems. Such tasks include acquisition by applicants of knowledge and skills necessary to work with modern geographic information system, and formation of skills of future specialists in the practical use of standard geographic information system to solve applied problems, in particular use of mapping skills in design and operation of alternative energy stations, use of instruments of geospatial measurements on the Earth's surface, assessment of the suitability of land allocation for alternative energy station, vectorization and geometrization of areas allocated for renewable energy sources, analysis of climatic condition and their impact on the georesource plantation of the environment, remote monitoring of sites and operation of the alternative energy station, management of information on electricity generation and the distribution on real time, planning and management of energy production resources. The introduction of the discipline GIS for renewable energy resource specialist in the educational process of training specialist is a field of RER pursues three groups of goals which are described in table 1. Based on the results of the analysis and the task of developing professional competitions with the discipline GIS for renewable energy resource specialists, the author team was chosen as the leading toolkit of the course CAGA GIS. Rationale. CAGA GIS abbreviation for System for Automatic Geoscientific Analysis, specialized software designed for scientific geospatial analysis and modeling of open source data. Availability of the necessary functionality for training needs. The following types of data are supported: bitmaps, tablets, and databases, ERS data, vector object, and metadata. Legal and free use of software for the needs of the education process. Use under the GNU General Public License. Technical and hardware requirements of GIS, complements of the description of technical documentation. Measurement of the area of SA's Starokozache, Ukraine, Odessa region using Google Earth, and determining the average level of precipitation in Ukraine in the first quarter of this year, December, January, and February. Today, GIS is only gaining momentum in Ukraine, which is facilitated by several factors. Firstly, the reform of most branches of government in order to make their work more transparent and therefore efficient. Secondly, the development of an appropriate legislative framework, as well as the formation of a unified strategy for the development of the digital economy. For Ukraine, the use of GIS for the most part is characterized by the following characteristics. Narrow coverage, there is a significant growth potential, tendencies to develop their own software products based on existing GIT. GIS is not universal in nature, but is aimed at solving specific problems. The use for the most part of information and reference and cartographic function, insufficient use of the potential of the analytical capabilities of modern GIS, the feature of the system across platforms, the use of web service and cloud technologies, and integration with geospatial databases. Thank you for your attention. The team of authors who prepared this publication and report is present on the slide.